In this problem, we are told we have a random sample of 9 cell phones. A mean full retail price was $501 and the standard deviation was 176. Further research suggests that the population mean is 426.61. Does the t-value for the original sample fall between minus t sub 0.99 and positive t 0.99? Assume the population of full retail prices for cell phones is normally distributed. So the first thing I want to do is to find these critical values. Minus t 0.99, it'll be down here, and that'll be this tail, so I'm going to shade that in, and the positive t 0.99, and that'll be this tail here. In the middle, the area is 0.99. So 0.01 has to be divided up between the left and the right tail. And if I divide 0.01 by 2, this area is 0.005, and this area here is 0.005. So I'm going to need to find my critical values. This is the t99 and the minus t 0.99. And I'll just write down what I know. So I know n equals 9, and it's normally distributed. The mean retail price is 501.00 from that 9, and the standard deviation is 176.00. The population mean is $426.61. Okay, so I've written down everything I know, and the first thing I want to do is I want to find negative t sub 0.99. So that's going to be inverse t. The area is going to be 0.005, and the degrees of freedom, well, that's n minus 1, so that'll be 8. Second distribution, and I'm going to come down here to inverse t. The area is 0.005. Remember, inverse t is always left. This is 8 degrees of freedom, n minus 1. And this will be negative 3.36 if I round to 2 decimal places. The positive and the negative are always opposites of one another. This one will just automatically be positive 3.36. But if I'm thinking left area, then I have to add 0.99 and 0.005 to get the positive one. But I don't need to. I can just immediately say, all right, it's the positive side, but this will become 0.995. That's the area to the left of t 0.99. And big surprise, it's the opposite, which is 3.36 approximately. Now I've got to figure out where the test statistics, or t, is. I'm going to go to chapter 6.2, and I see this is my formula to find that out right here. So I'm going to plug my values into that formula. T equals x bar, which is 501, minus mu, which is 426.61. That's the entire numerator. So I put parentheses around it, divided by s is 176, which is divided again by the square root of 9. So I can put that in my calculator, and I'll see that that's approximately, t is approximately 1.27. The mean of a z or a t distribution is 0, so 1.27 is about here. And the question says, does the t-value of 1.27 fall between minus 3.36 and positive 3.36? And I would say, yes, it does.